Our goal here is to solve the following system, and we're going to write our system as our solution as an ordered pair. And if you remember, if you have two lines, the intersection of them is the solution. It's the 2 points, or it's the point x, y that makes both of the equations true at the same time. In this case, we take a look at our numbers. We have a positive 2, positive 5, positive 3, negative 5. I notice here that these two are opposites, so I'm going to use elimination. And what that means is I'm just going to add these two equations together. So we get 5x plus 5 minus 5 is 0, and then equals 12 minus 7 is 5. So then we divide both sides by 5, and I get x equals 1. So I have the x, but I still don't have the y. So at this point, I can pick either of the two equations to do a substitution. So what I'm going to do is I'm going to pick the first equation. So it's going to be 2 times 1 plus 5y equals 12. And then this is 2 plus 5y equals 12. Subtract 2 from both sides. So we get 5y equals 10. Divide by 5. And then I get y equals 2. So here I have a solution. It's going to be 1, 2. Now once I get that, it's in my best interest to try to check that. So I use this equation, the first one, to try to solve for y. I'm going to use the second one to check. So to check, I'm just going to have 3 times 1 minus 5 times 2. So 3 times 1 is 3. Negative 5 times 2 is minus 10. And sure enough, that equals negative 7. So that does work. All right, for level 2, we are doing the same thing. We're solving the system. This is a little bit harder because it's going to require some sort of multiplication. So I look at my numbers. I have 3 and 6 and 2 and 5. And what I notice here is if I just double this top equation, then I can have that 6. Now this is a positive 6, so since I have to already multiply the first equation, I'm going to purposely multiply it by a negative 2 so that I can do elimination similar to how I did in this first part. So by multiplying by negative 2, I get negative 2 times 3x is negative 6x. Negative 2 times negative 2y is positive 4y. And negative 2 times negative 21 is positive 42. Now you do need to be careful because a lot of people forget to multiply all 3 terms in the equation. So a lot of people will stop here, but you do need to multiply both the left hand and the right hand side. Otherwise, it's no longer going to be equal. So make sure to multiply everything. Once we get this, we now have opposites. Negative 5y plus 4 is negative 1y. And then negative 45 plus a positive 42 is negative 3. So I get y equals 3. So I'm going to use my first equation to solve for x. I get 3x minus 2 times 3 equals negative 21. I'm going to add 6 to both sides. So 3x equals negative 15. And then I'm going to divide by 3. So I get x equals negative 5. And then I'm going to use the bottom equation to check. So I am checking 3. Oops, I'm not checking 3. I'm checking negative 5, 3. So negative 5, 3. This is what I'm checking. And I'm going to use the second equation. So 6 times negative 5 minus 5 times 3 equals, so I get negative 30 minus 15, and that equals negative 45, which is what we wanted. So this is our equation, or our solution, I should say. All right, looking at this one, I'm going to multiply the first one because it's simple enough. If I multiply by negative 3, I can get the opposite. Surely enough, you could multiply these two. I can multiply this by a positive 2 and this equation by 3, and then we would have negative 12 and 12. But if I can only multiply, if I can eliminate by only multiplying one equation, that's always the way I'm going to go. So I'm going to multiply this by negative 3. So I get negative 3x plus 18y equals positive 90. And now I can add them together. That cancels out. 4 plus 18 is 22y. 90 plus 20 is 110. So then I divide both sides by 22, and I believe that should be 5. So y equals 5. I'm going to use the first equation to solve for x. So x minus 6 times 5 equals negative 30. I'm going to add 30 to both sides. So I get that x equals 0. So my solution as of now is 0, 5. And I'm going to use the second equation to check. So 3 times 0 plus 4 times 5 is going to be 0 plus 20, which sure enough equals 20. So I can say that this is definitely my solution. Level 3, we are determining the point of intersection of these two lines using the elimination method. Just so you know, this sounds pretty fancy, but that's actually what we were already doing. So I'm going to write these next to each other and just put them in system notation. So I have 2x plus 5y equals negative 18. And then I have negative 5x minus 3y equals 26. Now this one is more difficult than the level 1 and level 2 because I have to multiply both equations by some number in order to eliminate. So we either need to multiply 2 and 5 or the 5 and the negative 3. I think that I'm going to go ahead and multiply this top equation by a positive 5 and the bottom equation by a positive 2. So I'm looking at eliminating the x's. So if I have both of these equal to 10, one's going to be positive, one's going to be negative. Okay. Now you could have done the same thing here. I would have multiplied this by 3 and this by 5, and then we would have eliminated the y's instead. All right, so distributing the 5, I get 10x plus 25y equals negative 90. And then here I get negative 10x minus 6y equals 52. I see I could use my calculator here. All right. 25 minus 6 is, I think that's 19. And negative 90 and 52 is negative 38. And so then I can see if I divide that I get y equals negative 2. I'm going to use the first equation to solve for x. So I get 2x plus 5 times negative 2 equals negative 18. I'm going to add 10 to both sides. So 2x equals negative 8 divided by 2. So I get x equals negative 4. So now I'm going to check negative 4, negative 2 using the next equation. So I have negative 5 times negative 4 minus 3 times negative 2. And then this is a positive 20. And this is a positive 6. That equals 26. That works. And sure enough, this is our solution. Okay. Find the value of 2x plus y given these two equations. All right. So what we're going to do is we are going to find the x and y that work for both of these, right? But instead of writing our solution as an ordered pair, we are then going to put our solution into this notation. So let's take a look. We have, I'm going to rewrite this one. I'm going to subtract 2x from both sides. And what that's going to do for me here is when I write it in the system notation, I'm going to get negative 2x plus 7y equals negative 13. And then my other equation is negative 9x minus 4y equals negative 23. Okay. So both of these are negative, but here I only have one positive and one negative. So I'm actually going to eliminate the y terms for this problem. So then here what I'm going to do is multiply this by 4. I'm going to multiply this by 7. And then we can go ahead and do that. So 4 times negative 2 is negative 8 plus 28y, get the x in there, equals negative 13. That's going to be negative 52. And then here I get negative 63x, and then minus 28y equals 7 times 3 is 21. 14, 15, 16, so negative 161. Does that sound right? So, I'm going to just double check that really quick with my math here. Because, you know, so we have here 7 times 23. Ooh, that was right. Okay, so I'm going to add these together. Here I'm going to get negative 71x, the y's cancel out, the y terms, equals, and then this is going to be negative 213. I'm going to divide both sides by negative 71. And then we get x equals 3. All right, now I'm going to go back to my first equation and plug in. So I have negative 2 times 3 plus 7y equals negative 13. So that's negative 6 plus 7y equals negative 13. Add 6 to both sides. 7y equals negative 7. So then y must be 1. All right, so we can check to make sure these points work. So I'm going to use this equation. Negative 9 times 3 minus 4 times 1 equals, supposedly equals negative 23. Here, negative 27. Ooh, I didn't get that. Oh, this should be negative 1. See, good thing I checked, you guys. This is a negative 1 here. Negative 1. That's important because then this becomes positive 4, and sure enough, this equals negative 23. See, that's why we check, just for those little errors right there. So that worked out well that I ended up doing that. So now I feel confident about my x and y values. So now I want to find this value, 2x plus y. So the value 2x plus y is going to be 2 times 3 plus negative 1. So 6 minus 1. And the answer then is 5. And then the last question here, we have on the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket, and the total was 38. The school took in 52 on the second day by 3 senior citizens ticket and 2 children's ticket. So they want us to find the prices of these tickets. So it's simple enough to set up an equation. I'm going to let senior citizen tickets be S. I'm going to let the child tickets, the cost of the child tickets is going to be C. So I get 3 senior citizen plus 1 child ticket was $38. And then I got 3 senior citizen tickets plus 2 children's tickets equals $52. So if I just subtract these two, so by that what I mean is I'm going to subtract all these terms and then I can add them together, then what's going to happen is I'm going to get negative C equals, and then 38 minus 52 is negative 14. So the child ticket is $14. So then I'm going to plug that into the first one. So 3 times the senior citizen plus the 1 child ticket, which is $14, is 38. So 3S equals 38 minus 14 is 24. So the senior citizen ticket has to be $8. So the senior is $8 and the child ticket is $14.